Seve, how you doing?
Pretty good. How you been? It's been a week, but it feels longer for some reason. I don't know.
It's been a week, but it feels longer. I mean, there was a big gap before I saw you last time, and last time you were still pretty jet lagged.
That's true. So, I guess I've been getting back into it, discovering the world I missed. You know?
Sitting down every night and coding hard.
Yes, and just coding. I'm about to hit 10,000 GitHub contributions this year. That's my goal for 2025.
That's a lot. Does that count like a comment, or what's like the minimum viable contribution?
I think it does count. I think it counts pull request reviews, issue creation, and direct commits, but I always do my commits and pull requests. So I think if I do a pull request with like 10 commits, those will all be counted. I'm guessing.
As each. Okay. That makes sense. You got to maintain that GitHub grass, right?
Yeah, you got to maintain the grass, but yeah. I just, it's kind of like, even in Taiwan, I had quite a few commits there, and it's just because I like bake GitHub into my everyday workflows. Like I do half my reviews on my phone.
GitHub is part of everyday life.
It's part of everyday life. You know, you gotta have it. And like you can even move things like documents. Do you guys do like requests for comments, like these kind of like long proposal documents?
Yeah, we are no. Well, I mean, we're a young company. We both are. But we had to play with the concept, and I think where we landed is a sort of happy medium, at least for the second, was the GitHub discussions. We're about to kick off after this sort of current body of work, a packaging system or a bigger packaging system. And we've come up with this concept of packagelets, where we want to be able to basically scrape all of the Atto code on GitHub or open source on the internet, obviously permissively licensed, and package sections of that code, the useful modules from that code, as sort of sub packages. You can imagine this just like a Python wheel, just like a sub package or a source package or a source distribution. And with a bit of metadata about the original author, of course, the license. Yeah. And then shoot that up to our packaging system, and then be able to sort of register those as like buyer beware. We kind of just extracted this from something, and it may or may not work. It was just there. We don't even know if it's been built, but it exists and it's usable, and so it might be a good basis for you to build on.
It's a really good idea. It's like there's so much in like when I look at the NPM ecosystem all the time, the
so
node package
big.
manager, it's massive. And I'm like, if you wanted to like bootstrap something like that today, by the way, I kind of think JavaScript and Python and anything with these huge registries is a little bit irreplaceable after AI has been introduced and exists in the world. Like it freezes these things. Yeah, because the AI knows of all of these things and has such a rich foundation. But anyway, if you wanted to recreate that foundation, in our case, we have to. We haven't existed for the decades that so many of these other pieces of software have been made to kind of like litter their little bits of code all over the internet. How do you do it? I think AI is a great way to do that, to bootstrap that process. So that's a really, really good idea. The AI goes on GitHub, looks for permissively licensed auto code, and then like packages it for them. So you're almost doing the original author kind of a favor, right?
That's the hope, right? Yeah. So we want to basically, and this is what is in our request for discussion, request for comment, but in GitHub discussions, basically the proposal is that we run a scraping job. We'll go through GitHub and find all the auto code, and then analyze it in some way to work out like which chunks might be useful in some sense. Maybe it's a complexity algorithm, maybe it's using AI, and then package that up with the metadata and publish it. And then when a sufficient number of people use it or it gets enough traction, notify the original author and be like, hey, Bruce, like your package is getting some love, man. This is some cool stuff. Do you want to actually maintain this and like turn it into something real?
Absolutely. There's so many cool things about this, but one thing it immediately reminds me of is there's this startup called Fisherman.
Okay.
And I was going through the Techstars program in Boston, the accelerator, and they had, and this company stuck out to me. They weren't even in the accelerator, but their strategy stuck out to me. What they were doing is going to small businesses that didn't have a website, generating an entire website for them. And like everything's there. It's got
they went out fishing.
Right. But everything would be there, and then they would go to the small business owner and be like, "Hey, your site's ready. Like, pay $10 to get it."
Yep.
And that worked. I think they got like 50,000 small businesses in like a year, just from generating all of this data.
But not trying to be too big at any one time. You know, just like, hey, look, just like come grab a website. Like, we'll make it easy.
Yeah, yeah, something like that. So
cool.
I really like that. So the tricky thing about package creation, I think, is the granularity. Like, we have this problem with tscircuit where I was like, okay, everybody, like, create a GitHub repo for each of your like modules or whatever. And then like people are like, oh, so like a voltage regulator, and it's like, well, yeah, okay,
that might be a little small. Like,
it's a little small, but then they're like, okay, well, here's an ESP module you can plug anything into, and it's like, well, that's, you know, maybe that doesn't have enough flexibility, or maybe you're making too many opinionated things, so the part availability is bad or something like that. So it's hard to pick the right level of granularity.
Oh,
do you guys
super.
have like an idea on how to do that?
Oh, no. I mean, we've been learning all the same things as you, right?
Yeah.
Because it's kind of wild. You come from a software space where some of these concepts are really mature.
Yeah.
You have it, like, there's a good idea, and there's, you know, some packages will state this is an opinionated framework to do X. Like, take this back a step. What is, like, this opinionation is not something that is prolific in other disciplines. You don't go to a Mackie or an EE and you say, oh yeah, we have an opinionated framework. They're like, a framework? You mean like girders for the building? Or are you talking about like, you know, like, what do you mean? And so we have this like rich, deep, conceptual, social infrastructure for it that doesn't exist elsewhere. And I've honestly felt a little floundery without it. It's a little hard to rebuild it sometimes. Yeah. And where to align things, you know? Similarly, we started off saying like, okay, just make a repository per module. And the, you know, a module, or I guess you could say one module per package and a repo per package type of deal. So up the chain. And the modules that we started off with were as simple as like adjustable regulator, and it's a single LDO with a voltage divider and the, you know, the equations of such so you can configure it. And it's like, that's kind of neat and all, but as soon as you end up with versioning, you know, this is why companies like Google, obviously very famously, but Tesla as well for their firmware, go with a monorepo because you don't run into version conflicts. Because as soon as you go to uprev something that you use that voltage divider in, you're like, oh, actually, instead of speccing the total resistance, I want to spec the quiescent current. Yeah. You're like, API change. No. And so, that's been rough at the moment in particular because we're going for a 0.3 big uprev. And oh my God, there is a lot of stuff out there that you try not to make breaking changes of, but if you don't design APIs well, and you're obviously young, it means that there are typically some things that are very hard to reconcile.
Exactly. It's like you want to take the path of least mistakes when designing these APIs. And like, it's funny because somebody will have a very simple feature request, but it's like, it sounds great to me, but can we commit to that?
Firstly, love the energy. Would love to do that. Secondly, that actually sounds impossible. It's like the XKCD comic from, you remember the one where the XKCD, fantastic comic strip. You know him. I think everyone in the program work does.
I think they cover kind of everything. It's not like just software. The guy is just kind of like, he's one of us. He's just a nerd, you know? He's just a nerd who's into lots of things.
Yeah, but it seems like every software engineer knows him, you know? But the one that came to mind is, you know, the boss goes up to some PhD like higher in the company and says, hey, can you geolocate these photos down to the precision of sub-centimeter anywhere in the world? And the PhD is like, yeah, no worries. I'll just add a few lines of code for geotagging this and that. It's like, hey, could you tell me if there's like how many birds there are in this image? And she'll like, yeah, that'll take 8 years and some millions in research to work out. Back in the day, of course.
In the day, although I wonder if you took the date of that comic and extrapolate, I wonder if about 8 years later was when that started becoming
someone
common.
Saw it and thought, actually, that would be a great...
I'm going to get a PhD on this. But back to modules, a really interesting analogous problem in the TypeScript world is we don't know how to use our version numbers. Totally.
So is there a standard versioning system for TypeScript specifically?
So the whole JavaScript community uses Sumver. I think.
Thank God.
Python, I think Python might be a 50-50 land with some of our...
Python's the Wild West. Python, I mean, it's an interpreter language that is kind of, to some degree, philosophically have one right way to do everything.
Right, that's right, yeah.
Philosophically.
There's the Python way. I forgot about that, yeah.
That's not how it comes out in practice. Yeah. So, no, semantic versioning... I wish were more prolific, but it is certainly becoming so. But it's behind on the heels.
So for what it's worth, I don't love Samvar. I love to shell my or sell my own thing.
Snake oil.
Yeah, my own snake oil. I have a versioning standard called pragmatic versioning.
Okay.
Pragmaticversioning.com.
Is it actually?
Yeah.
Oh, and you made this?
Yeah. I proposed it. It was on the top of Hacker News very briefly. But,
nice. How long ago did you do this?
This was over a year ago. Yeah.
Cool.
Yeah. And then there's some utilities that help you release with pragmatic versioning.
Okay, and what's the scheme of pragmatic versioning?
The scheme of pragmatic versioning is that versions are mostly used for marketing.
Interesting.
And that's how, so a lot of companies start with Semver, and that works until they hit a scale where the versions are basically used for more or less for press releases, and people just ignore the version numbers otherwise.
Yeah.
So
Apple 14, not semantically versioned.
Yeah. So it takes this and it tries to create a framework that is pragmatic to like what actually happens. And if you look at most major release things, like even Node itself, even though Node promotes Semver everywhere, they don't use it. They use kind of like we do a release every 6 months or every year, and it goes up by one. So it tries to stay in tune with that while also being Semver compatible.
Integer releases.
Yeah, basically. But anyway, okay, so
practical. Practical version, you called it.
We have to come up with a scheme for hardware that makes sense, because in the TypeScript world, we have this problem where we don't know to do patches or minor releases when the runtime doesn't break, but the types do break. So that we for example, refine the types. We make the types better, right? So technically it's a fix, but it will cause consumers to...
It'll cause breakages.
It'll cause breakages, but not runtime breakages, just like static breakages, right?
Okay, so dev breakages.
Yeah, exactly. You'll have to go like fix an error that literally a bug you have in your code. So the same problem kind of exists with hardware. Like if you swap a part in your circuit module because of part availability, what is that, a patch? Is that a minor release? What if it's functionally the same, but obviously it's not truly the same? You could have some strange issue because of the new chip. How do you apply... So the question's, I guess to some degree, you could reframe it as how do you apply semantic versioning to hardware, and can you realistically, pragmatically? Exactly.
So, I mean, one, you could definitely argue based on its backwards compatibility, just like semantic versioning. Don't bump a major rev unless you've changed where the bolts go. For argument's sake, it screws in the same place, it does the same job, it should perform in the same circumstances, etc. But that's the same circumstances is where it starts to get fuzzy, because that's where, at least in a lot of hardware today, I mean, I guess a lot of software too, like with, you end up validating things at a system level by the fact that it's been out in the field for a long time.
That's right.
And you trust it. And you get something new and you're like, the guys we bought it from said it did the same thing. Like, does it? Yeah. Yeah,
I don't know if I would use the 3-number versioning system for hardware. And I think that's actually the most important thing. And you're doing a registry now. We're starting to do a registry. It's like, what I want to see is, has this been validated physically? If you have a physical photo of that circuit, even the fact that it can be assembled is a really big deal.
You have to put it's like the kind of old school days where you got a newspaper and you put your circuit board on top of the today's New York Times to prove that it actually...
Yep. There's so many things you want to track with hardware. I don't know if this is a solved problem. And
it's definitely not. I mean, every big company, so whether it was Lilium or Tesla, everyone comes up with a versioning system. And unlike the software world where things are fairly stabilized around a handful of very common schemes that everyone kind of gets. Like semantic versioning, you just send them the link, and at the bottom, actually, it says Tom Preston Bonner at the bottom. It's his as well. Same guy who created TOML and GitHub.
Really?
Yeah. He's prolific. I know.
Whoa.
I know. He's
huge.
Nuts. He's awesome. He's done so much. But you send him a link to semver.org and it explains exactly, it's a great breakdown of exactly like, here is when and why and how and et cetera to do. And sometimes obviously there's some fuzziness in the real world as to how to actually apply that, but the concepts are super clear. And I mean, explain pragmatic versioning. You didn't actually, like, what does it mean? Is it just the integer count or?
So pragmatic versioning tries to be SemVar compatible. So it's good to start in the frame of mind of SemVar.
So three integers?
3 integers.
Yep.
The patch, the smallest version, is any increment of your software.
At all, yeah.
Any increment.
That makes
Every
sense.
single release goes out. And that's to prevent this issue where like people are like waiting on a version or something, or like you don't have a version to reference because so every version is an increment.
And that's every commit to main, is it?
Basically every commit that builds. So if it can build, then you get an increment.
Oh, even in just like a PR, everything, not just everything that merges to main. Whoa.
Yeah. Well, no, not every PR. Everything that merges to main.
Everything that merges to main. Yep.
I do think though there's a huge space for like people want to try a branch. So there's a company in the JavaScript ecosystem called StackBlitz that is trying to solve that problem, and they actually publish every branch to this big registry. But anyway, for pragmatic versioning, your first number is your increment, your second is your announcement, and then your third is your big release. Okay. Yep. So big release is the most important for marketing. Even people who are very SemVar oriented will save that big number.
Yeah, they're like,
right?
I kind of want to kick up the one.
yeah. Like I remember at Seam and some other projects I was working on, people would just kind of willy-nilly upgrade that major number, and you can't roll it back.
Whoa, guys, come on.
It's like, that's our version 2. Like, we changed an API in a breaking way. Like, I get it. And like, there's, have you ever heard of sentimental versioning?
No, I haven't. But
it's somebody who makes fun of exactly what I'm saying right now. Like, don't get sentimental about your versions, is what they say.
Yeah.
But the reality is we're very sentimental about our versions. We want to reference the giant release.
We're emotional monkeys.
We're emotional monkeys.
See, that's actually, I do think that SemVer does account for this in a good way, in the sense of at least for pre-version 1, where before version 1, the rules are off, they're relaxed. If I remember the precision of it and at least how we implement it, fingers crossed, appropriately. Sorry, Tom, if we goofed that up. But the minor releases are considered breaking and the patches are just rolling, And so until version 1, you're in the Wild West, you know?
Yeah.
And I think that makes sense because, I mean, at the start of every project, things are erratic. So it makes perfect sense that you do it that way.
Yeah, the other thing pragmatic versioning acknowledges is that some of our authors rarely go back and actually fix a major release to add a patch. Big projects will, but those projects are rarely even using SemVar. So, so like you're not going to go back to version 1 and release a patch, probably. People do it,
after you've released 2.1 point whatever, you're not going to go back to 1.1 and then bump it because something.
Even if there's a bug, you're more likely to say just go to version 2.
Okay,
right. Stop using those old APIs.
Yeah, interesting. I was thinking about this just the other day because we are currently our currently released recommended version is 0.269. And would I bump it? Well, one, I kind of like the number and it's funny. And I don't really want to bump that version.
As destined, as Elon would say, right? Every time anytime there's a 69 or 42 anywhere.
It's a good release. But I would. I think there's a bunch of people using it at the moment for production stuff that matters, or I should say, low volume production stuff that actually matters.
Right.
And so I don't want to cut them off in some way. Even actually, there's some behavior in 0.3 that we've fixed. That we've noticed there was a duplicate definition of something in a commonly used package, and the first compiler ignored it and just accepted the redefinition and shadowed it, and they're identical, so it doesn't matter. And the new compiler says, duplicate, like refuse to build, and that is correct behavior. That was as we specified in the language and told people we were doing, and we actually just goofed the implementation in our early compiler.
Is there an atopile specification? Like, did you guys kind of separate that from the implementation?
The Atto language, that is? It is separately defined in the sense of there's like grammar files for it. So there is a proper synaptic definition of it. And then there's documentation that explains how it's supposed to work that should be tied to the compiler pretty tightly, but sometimes varies. And we go out and define a little bit more of the intention so people can write ahead. And for example, for argument's sake, say we hadn't implemented the maximum voltage on a capacitor, we just implemented the capacitance or the value, then you know that, oh, okay, I'm designing this and the current compiler won't honor this max voltage, but I can put it in there and it'll accept it because it's, it just globally accepts additional parameters that we define. And you can extend that and sort of import from futures type of concept.
Yeah. For anyone who tries to create an electronic software programming framework, of which really is anybody else alive doing this except us?
And Duncan. Hey Duncan.
Oh, Duncan, fuck me. Sorry, Duncan. But to any upstarts
and Skittle as well.
Skittle, are they alive?
Dave Van about is his name? Yeah. Anyway, he's alive and kicking. Okay. They're doing good stuff. They're actually they're used on a few things like bits and pieces, but it's an OG really. It's been around for 5 years.
You got to respect the
respect the G's.
It's the funny thing about like web electronics is the entire ecosystem. I think it died about a year ago. Somebody can yell at me if I'm wrong.
Web electronics.
Yeah, like
how do you mean? Explain that.
Like people doing electronics with sort of JavaScript and like playing with it and building libraries. Yeah, like.
Isn't that what you're doing?
That's what I'm doing. Yeah, no.
Wait, but there were other people doing that.
There were other people doing
like
it. Yeah, there's a lot of like ancient kind of tracks, right? And I even spoke like 2 years ago because I've been thinking about tscircuit for a really long time. Yeah. 2 years ago, I like spoke to some of them, and they're just like they're just not doing it anymore. But it's crazy. If you look at like PCBWay, their Gerber viewer, that's one of the ancient. Ancient is like 5 years, but still they're all gone. And it seems to be there's one guy, Dr. Chitness, if you're out there, one professor in Edinburgh who ported Spice to web. Edinburgh
in Scotland. Scotland?
I think so.
Edinburgh.
But anyway, to any upstarts trying to create a new framework, you have to decide this trade-off of like, you want to be generous so that your users aren't like frustrated using your program. You want to have generous acceptance of inputs, but you also need to maintain that API because you can't break people's stuff. Yeah. So good luck with that tension.
You know what? I do agree. It is painful, but actually the equations around this have meaningfully changed, like really excitedly in the last couple of years. Obviously, partly with an enormous amount of AI, right? It's become both easier to write tools to deterministically upgrade things. And like in our case, we spit out 1 million warnings. Well, it's not that hard for us to go back and automatically fix them.
That's right.
Just you run auto fix kind of deal. And with the assistance of Cursor, what could have been, and like, honestly, just like great packages, a great package ecosystem these days. It become a lot easier. But then with Composer View and Cursor, for example, you're like, hey, go through and fix this part of this entire repository, and it's like you got your boss, and we'll do it and do it well. Yeah. Because it was one of those Gerber viewers. I can't remember whose it was, but I was doing a similar thing, processing some Gerbers a couple of months ago now, and I came across this ancient library that was unmaintained that had a top of the README said, hey, go check out this other guy's fork of this and that and blah, blah, blah. You follow the chain through, and eventually got to one that was semi-maintained. It had 100 odd commits and was used by a reasonably large PCB manufacturer in the States. I forget their name. But I looked at it, and I mean, TypeScript's the same, and C++ and all the big languages. But you look at it and you're like, dear God, what is this, 2010? Like setup.py? Like what? Big at a pyproject.toml in here. Like, why are you using this? Come on, hatchling, let's go. And then like rough for checking and this and that. But normally you'd look at this and you'd be like, you're insane to upgrade one of these projects. Why would you? Well, it took me 15 minutes.
Yeah.
And now the tool set is modern and like good to develop in. I added typing, just like add typing. Go,
wow.
It's great.
Okay. That's pretty cool. I hadn't thought about that because Python projects without types, that's a huge value add. But what is modern Python now? Because the last time I used it, it was Poetry, but I've heard about UV. Is that
UV's
okay? So UV is the way to go.
UV is where it's at,
Okay.
What's his name over at Astral? Like, oh my God, is he good? He's so good. I can't believe his name's slipping my mind, but God, so the story, you know the story behind Rough and Astral?
Not really, actually.
Okay, so are you familiar with Rough?
Rough is, I believe, a linter?
Yeah, exactly.
Okay.
Rough is a linter, so it's like PyLint, PyFlakes, a linter, just kind of like a static checker, not just the types, but also for lines being too long, your imports are out of order, just kind of code smells in general.
Yeah.
And so it will go through, it'll lint your code and dump out a bunch of errors, and it can help fix a whole bunch of stuff. It'll do formatting, and these exist. I listed off a few more.
Yeah.
But the cool thing about Rough is it's completely implemented in Rust in a modern way. It's ballistically fast, and that's the coolest bit. And it's a drop-in replacement for almost all of these existing tools. So just snap out of the box, and it took the whole Python ecosystem by storm. Like everyone overnight was using Rough, including us, of course, because it's just awesome.
Oh, wow.
And then the guy who created it just sort of doing it on the side of his project. He's clearly so good. Like you look at this thing, you're like, man, you nailed it.
A cracked engineer, or whatever word we're using.
Yeah, absolutely cracked engineer. Oh my God. And so he went and raised $4 million. I'm not really sure what the pitch was for, because it's an open source tool, right? Completely open source, not open core, open source, runs locally.
It's like a whole diagram of these companies that are like, we rewrote it in Rust, and they just get money dropped on them. I think Void Zero is another one in the JavaScript land, and I'm like, how? It's all free. What is going on? But anyway.
And so that's where Astral came from. That's what the company Astral is. And then Astral created UV, which is kind of like Pip and Poetry together. So Pip being the package manager, and Poetry being an extension on package management that also provides file locking or dependency locking and better resolution because of that, and a handful of other niceties.
Yeah.
But it does it also ballistically fast.
I think it does
UV, that is.
Virtual environments too, maybe, because that is one thing I'm just very bad at it. I feel like Poetry is the only way. I'm like dated. So Poetry is the only way I know how to use Python. With UV, can you do the same thing where you can just run a Python file? Yeah.
So with UV, it will just assume that you want a .vn virtual environment within your current project. And if it doesn't exist, it'll make it and sync those dependencies for you. And so you just UV run whatever.
Oh, perfect.
And
all right, I'm switching to it.
Absolutely. Yeah, because atopile sort of a combination or a merger of a few projects. We had some manual pip environment and pipx which came out as well to do like global, but UV tools the same thing but better. And Hatchling for build infrastructure, which we actually still use underneath UV. And then from the side, there was Poetry, and we're like, nah, UV through and through. And that was a half-day exercise to switch over to everything. And magnificent.
All right.
Highly recommend.
I'm sold. That's really interesting. I think it kind of gets into, we were talking a little bit about Mandate of Heaven last time, and when you have a project, like Python has had so many projects that kind of held the mandate too briefly, right? Yeah. And so you've got the equivalent of a warring states period. I'm reading about Chinese history right now. But literally there are so many solutions in the Python ecosystem. So being like, of the few electronics frameworks, our opinions will probably persist, which is kind of like...
terrifying.
And, also it's an opportunity to do things correctly and consistently.
Definitely.
That's nice.
try hold at least some consistency.
So don't fork us and introduce a competing standard, please. Especially not in Rust. By the way, did I ever tell you this? My biggest fear is somebody forking tscircuit and doing it in Rust.
Your fear? Why?
Because it would probably lock it down too early. Like I want the spec to evolve and be able to do a lot.
It's funny you say that because it was actually just yesterday that we're now officially a real project because someone raised an issue of why don't you rewrite this in Rust on our repository? Yeah, man. Put it there. Like,
well done. A major milestone. Congratulations.
2K stars? Irrelevant. Like,
Does Atto, does it take time to build? Like, is there, like, I feel like maybe it's because we don't, actually, you had a really big board the other day. I was looking at your cell sim board. Actually, maybe we could talk about that for a second. Yeah. What is the cell sim board? This massive board made in atopile.
So CellSim is a battery cell simulator. That's what it's short for. It's a piece of testing equipment that you need if you're developing basically any big battery powered thing. It can emulate in the real world, simulate, I think it's 12 channels. It might actually be a little bit higher because it's obviously super configurable, but that specific board had 1,200 components on it, can emulate 12 channels. And it's really cool architecture. Narayan's a genius. But he had so he's got a isolated DC to DC converter on sort of one side, and then for each channel there's an Atto module. So it's trivial to pattern these, and then it goes into a buck regulator to cut that 5 volts down to whatever target voltage you have for that cell, plus a small, I think it's 1.1.5 volts. Then you have an LDO cut off that last 1.5 volts because it's much easier and cheaper than having a whole bunch of caps, and you get perfect ripple out that way. You got a 2 DACs to control those. An I2C isolator back to your ESP and control infrastructure, and then 2 sets of relays, one to a DMM output for like validation of the cell sim itself and like inline testing of like high precision voltage measurement, and then one out to whatever you're connecting to and trying to exercise the device under test.
So the cell is battery cell, not cell phone. Okay. All right. I was looking at it, I was like, why do you need to test 12 cell phone? Okay. So you can test 12 battery cells, and then you could hook this up to...
It's actually the opposite. It's pretending to be a battery cell.
It's pretending to be a battery cell.
Pack in that case, yeah.
Gotcha. And then you could hook this up to something you're using to test battery charging algorithms or...
Yeah, it's actually made for sourcing typically. Okay. So it's for BMS development is like the primary motivation.
Okay. Cool. Wow.
It's a cool architecture though.
Is this like, I don't know how much you could say about this, but is this like a niche market? Like, because there are a lot of EV companies now, and there are more and more every day.
No, totally. It's not a big secret, and the cell sim's open source. It's open source hardware.
Oh, nice.
And so the premise was that we have a little bit of expertise in this region. We've worked at a few EV companies, flying and grounded, and it's so today, like, validating hardware is like this really arcane manual process of going and poking it with really high precision instruments. Yeah. And or particularly Narayan at Tesla, was extremely embedded in automating that validation. And he built basically a line and instrumentation to do this. And, in a thermal chamber, so it would exercise the boards over their full temperature range and blah, 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 like an enormous amount of really cool stuff. Yeah. And I was responsible for the testing program that coordinated similar but end of line system level testing on the Megapacks. Yeah. And so we've both been heavily into this world of validation, and it's just like completely insane how manual and cruddy the tool set is. And so when we're there's a project design partner of ours at Atopile that's launching satellite batteries early next year, and it's a Atopile design BMS that's going on them, and they needed to test their hardware, and we said, well, what better opportunity than to create this? We can open source the design. Obviously, our design partners get to use it, and we can show everyone how we think testing should be done in an opinionated fashion. Hardware validation, it's actually insane. At the moment, it's Hill Engineer seems to be about the most prolific job title here in Silicon Valley. You know what a Hill setup is?
I have not heard of this. Hill. Wait, hardware...
Hardware in the loop, yeah.
Oh, hardware in the loop. Okay. Yeah. So this is a prolific title in Silicon Valley?
They're trying to hire for at the moment, because you need this kind of embedded persona. You need someone who can write firmware, a bit of a tool stack on the software side of things to coordinate all the testing, and actually like design ideally the hardware as well to either go around whatever board, device, etc. you're trying to test, or even just you clip it a little further in and you cut it at kind of the microcontroller level and then exercise the microcontroller directly. And so you can test your firmware all the way through some of your hardware design, all the way through to the system level, of course. It's the most extreme level of this.
Yeah. When does a company realize they need a Hill engineer? Like, what's the...
Too late.
Too late? Yeah.
No. I think that... So probably... Tesla does a good job of this. Tesla does a great job of this. And Tesla has obviously gone through a bit of a generational change and a lot of engineers have left.
Yeah.
Out of that, I've seen some of my good friends over at Zealous Cloud have started basically a Hill test infrastructure company. Right?
Oh, that's cool.
So like this is becoming prolific. All of the guys at MP Space, most of them are ex-Tesla. And so they're like, this is obviously how we do things. We automate the testing. We want the validation on the books in a database, just like we do in software.
Yeah.
And kind of the CI-like mentality. But traditional companies, and Lilium did it as well, but traditional companies don't, because they don't have same crossover between firmware and software and firmware and hardware.
Yeah.
And it's currently really only like globally prolific in the software world to expect continuous validation and integration type testing.
Yeah. And it kind of seems, I don't know if you have this impression, but I feel like in hardware, you probably know a couple of people like this who are absolute geniuses. They understand like all the EMF and they have this crazy view. They're going to know all the implications. Absolute wizards. I feel like these people are becoming less common maybe, but the stuff they need to do is still very important. And so how do you like codify all of their knowledge? Well, you run tests, you know, and then exactly. Yeah. So maybe that's why this is becoming more popular. And just generally, I think software has been more lucrative for a while.
Yeah, that's true.
For smart people. And like you
really have to love being an AE to go decide to do that when there's someone just around the corner that you have a really similar skill set for, and they're going to give you a 20% pay bump. Like,
that's right.
You know, you really have to love the art to stay there. So
yeah. I mean, how many? I know a couple EEs who have gone into software. They've literally graduated with their degree, worked in hardware, and then went, you know, I can make a little bit more money.
Happens all the time. Yeah. So
it
makes perfect sense too.
It makes sense that hardware is going to start incorporating software concepts just because our spectrum of competencies now leans software. Yeah,
you talk about a full stack developer. Well, in the hardware world, that means you can write software these days, right? Or at least some software, and it's an important caveat.
Right.
I think it's pretty cool too. There's like projects like Arduino, of course, which we think is being around forever. It's new in the scheme of things. And then Zephyr as well, which I actually haven't personally used, but a few people on the team are prolifically involved in, or were prolifically involved in it, and like it's the bee's knees according to them. It's fantastic. It makes development easy. MicroPython, of course.
What is this? Zephyr? You said it was?
Yeah, Zephyr is a project that defines like almost an RTOS, a real-time operating system for microcontrollers, as well as device driver standards and that type of thing, so that you can share across even microcontroller families and things with different peripherals.
Oh, cool.
Yeah.
Okay. Very interesting.
Kind of like how you might get an Arduino temperature sensor driver. It's that, but at like enterprise quality. You know, you wouldn't run Arduino code in production, but you can run Zephyr. Yeah.
That's very cool. Yeah. It's funny how often people use the Arduino C code to adapt to different microcontrollers and stuff like that. So this is kind of like a universal driver.
Exactly. It's intended as such. It has device trees like Linux and that type of thing.
Oh, nice. Oh, wow. Huh.
Yeah. So it's pretty cool. Pretty cool. Yeah. Something I definitely need to play with. But out of all of that, and the hardware, the Hill ecosystem's really evolving, and actually that's part of the reason we also got into the cell sim side of things.
Yeah.
I think it's an incredible first category that we can ride the wave with new generation electronics design tools, because you've got these embedded people with a really diverse skill set. And then all of a sudden, there are no standards here. You're not putting these things into production. You need 5 of them. You need them to be designed really fast because they got to come alongside the product, but they're not the product, so you can't focus on them. They need to work reasonably reliably. They can't be these cobbled together harnesses that they were from yesteryear.
Yeah.
And everyone wants them, but they need to be lower cost.
Yeah.
So it's pretty cool stuff.
The other interesting change, I almost feel like we should have given more time to this because this is very interesting. But have you ever heard of these analog discovery boards?
Yeah. Yep.
Yeah, I feel like that type of equipment that's really, really small, and you can literally just have literally just plug it into whatever and then have it read, all your signals on a scope. Yep. It's got analog discovery
as well.
Yeah. Yep. That's like a better version. So these are logic device. I don't know. How do you describe these?
So these are almost somewhere between a logic analyzer, or they're like a lab bench in a box with a logic analyzer, a low speed scope, signal generator, / function generator, that type of thing, all rolled into one, right?
They're all rolled into one, and then they're not like traditional oscilloscopes or logic analyzers where you have a screen and it's this big clunky box. It's kind of like small, and you use software to get most of the stuff out of it. Like you run the analog discovery program, or you can read it with Python and stuff like that.
Yeah.
So everything's becoming a little bit more software native, and it's cheaper too.
Yeah.
It's like
the Thunderscope we looked at a month or two ago was the same concept.
Yeah.
And I mean, it comes from the realization that you have a 40 gigabit bandwidth to your computer if you want it.
Yeah.
And so, how a digital oscilloscope traditionally worked is you had a whole bunch of RAM, like tens of gigabytes potentially, and you would absolutely slam a high-speed ADC with 0 compression, dump it into this RAM directly with an FPGA, fill the whole buffer, the whole 32 gig perhaps of RAM, in like a couple of seconds, really not that long, and then you would analyze it in post. But now getting up to what, 5 gigabytes a second to your computer is doable, right? Yeah. And so you can use your computer's RAM and you can offset all of that cost, and you basically just need the front end in a box, which is really cool. It's a great concept.
Yeah.
I think it makes sense for a bring up tool, and it's actually something that Ryan, for example, would carry around. He'd carry a Sail in his backpack in his little toolkit because they're magic. They're so good.
Yeah.
But it's a generic tool, and I think the really cool thing about new generation EE tools that have awesome package management and let you design things ballistically fast is it brings the flexibility from the physical world back into the design space.
Right.
Because having a really flexible front end like these analog discovery things does degrade their reliability. One, because you've got cables between it and your board.
That's right.
For example, and this shit just comes loose and it comes out, and someone puts it in the wrong place, or someone borrows it, God forbid, which we all know happens.
Yeah, absolutely. So can you have basically these digital logic analyzers, these oscilloscopes actually baked onto your board entirely?
Oh yeah.
Yeah, that's pretty cool.
That's where we're going soon. Cool. That's where we're going soon. So the SolSim was one foray into that. And then there's the software side of this. Please, please.
I just like, speaking of obviously we believe in our own hypothesis, but I see things that validate it all the time. This guy, I'm forgetting his name now, but he works on PCB stator motors. Is that?
There's a YouTuber I've seen who does. Okay, yeah. Brushless, like little PCB braced brushless motors.
Yes.
That one? Okay,
and the thing is it's basically like a PCB module where you drop this thing on your board. It's got all these coils on it, and then you buy one of his like magnets. He has like magnets compatible with different PCB modules. You drop that in, and you literally have a spinning component on your PCB.
Yeah.
Like, so it's
integrated inductors. Yeah.
It's like
planar inductors. Sorry. Yeah.
Yeah. So it's like, I can't think of a use case yet, except like obviously a drone is basically 4 motors, but it's like, wow, what can we do with that? If you can have like a huge array of spinning motors, and it's easy and it's cheap, Like, what does that open up?
Yeah, you can do a lot of stuff integrated into your PCB. You can do load cells, so trivial. You can just put a trace back and forward along it, or a couple of resistors. The smart knob does that actually.
Oh, really?
Yeah.
The smart knob is the knob that kind of like clunks when you...
It simulates all the feedback by just being a brushless motor that you're spinning. It's pretty cool. It's awesome. Have you played with
That
one?
is cool. I have not played with one yet.
Oh, I got to see one at open source, and it feels great. It's such a cool device.
Tactile feedback. Bring tactile feedback back.
Simulated tactile.
Simulate tactile feedback.
And then the other one is you can do linear motors as well with a PCB, trivially, which is pretty cool because you don't need to have like a gearbox or something. You can just have the magnet slide back and forth directly.
You can do that on just a PCB. You can have a linear motion.
Yeah, because you just have your coils, instead of wrapping your coils in a circle, you wrap your coils in a line, which is obviously annoying and hard to buy. But it's trivial when you're designing a PCB.
Yeah, that's true. That's a really big deal, especially having done a bunch of stuff with like IoT smart locks, at the end of the day, you're like, why am I paying so much for just a friggin' solenoid, right? It's just a solenoid.
They were solenoid actuated?
I don't know.
Some of them, I guess.
Yeah. How else would you,
gearbox and ideally.
They could be gearbox.
Because if you don't have a rack and pinion or the likes, or a worm drive or something, the problem is with the solenoid, you put a big magnet on the back and your lock opens. So the solenoid ones are insecure.
So one thing I'll say is the best smart locks, they would actually try to use that mechanical motion of the user to open it up. So they had some small locking mechanism and then something bigger.
That makes sense.
There's so much. I could do a whole episode on smart locks.
We should.
Yeah.
But maybe just back on the testing front real quick. Actually, one piece of infrastructure that I think is going to be enormous here, and I hope people leverage really fully, is PyTest. Because PyTest, if you're trying to orchestrate a whole set of testing on a hill test. So let's say this is a hill setup, so hardware in the loop setup. You have a DUT, a device under test, which is your product or your subsection of your product. And then you have your test infrastructure.
Yeah.
And your test infrastructure obviously starts at the PCB that exercises that hardware. You have some kind of, typically a microcontroller that collects that and shoves it off to a computer. And then you need something to actually orchestrate that. And you typically run this on like a Jenkins instance or a GitHub runner, that type of thing. So you can dispatch a job to it and keep it as part of your CI loop.
Yeah.
That's the goal.
Yeah.
That's what you're trying to get to.
It's the dream.
Magnificent. And then you can test your firmware in the real world and all sorts.
Right.
Which is pretty cool. But if you want to write a serial test, PyTest with Asyncio, and you can have now a concurrent feedbackable system to orchestrate all of your testing in hardware in just a procedural language. It is genuinely beautiful, and I highly recommend it.
Yeah.
And hopefully one useful piece of infrastructure here I just built yesterday is PyTest history. And so if you've got some flaky tests, which hill tests notoriously are, because you've got all this hardware involved, and hopefully custom PCBs that integrate things better will improve that reliability. They certainly should do. You need to know whether something's bad with your hardware along one axis or with your actual software changes on your branch.
Yeah.
And so you kind of want to see whether it was a software change that made you go from green to red or just time chronological.
Yeah.
And so yesterday I just wrote a PyTest plugin that stores all of the history of all of your tests in Superbase Postgres database.
Oh, nice.
And so you can look back at that and see what happened. And so hopefully with a few more of these things and a bit more standardization, Hill will just be the standard.
That sounds huge. I mean, I want that outside of PyTest because we have so many flaky visual tests, even just within software. Yeah. So there's such a large class of flaky tests, but hardware makes it even harder because let's say you're testing firmware, you might want to run it on one version of your hardware. You might also want to run it on a different version of your hardware.
You do.
Because even for the same product, like part availability, you can have different stuff going on for different runs. Yeah. So that's a really big deal, I think.
Yeah. I'm looking forward to it. It was actually amazing that the wisdom in software, of course, is we'll write fast tests that are reliable and deterministic. And if you need to cut your product down to make those unit tests rather than system end-to-end tests, then let it be.
Right.
And that is sensible. I do agree for CI. And we don't do job blocking PR testing like this. But with a regression required label on our GitHub, for example, conceptually, right? Or on main with some frequency, you run regression testing.
Yeah.
You want to see when things went bad.
Yeah.
And so I'd started working on this at Tesla and couldn't do it before I left for the energy products at least. But you want to run like nightly regressions on a version of each of the Megapacks with the current up-to-date firmware,
right,
and then deliver those bugs back to either the software team if a software change appears to have made the pack gone bad, or if the pack was already bad and it's still bad, then you want to let the hardware guys know so they can go fix the damn thing.
Yeah, yeah.
And so I think this type of automated testing is going to be huge throughout the industry in no time.
Massive. And then once we have this, the big problem with nightly regression tests, any regression test where somebody's allowed to merge before they get it, is you have to blame someone.
Yeah.
Literally automatically, or else it's kind of tragedy of the commons.
Yeah. But tragedy of the commons is better than tragedy of your users. You know?
That's true. That's true. And some companies do have good hygiene about like, hey, before this release goes out, we're going to fix all the regressions. Yeah. So like we're going to have that month.
you even at least need to know about it.
Yeah.
So again, talk back to Tesla. The way it was done there is there's a tool called SOFA, the sign-off tool, and every code owner would have to sign off that their little tasks had been done, that they agree that any of the regressions that had failed were not going to cause user strife or weren't regressions on existing behavior that was deployed and were just for future product improvements or, that type of thing. Yeah. And I do think that type of sign-off hygiene and responsibility is, it's necessary. You got to take ownership of things.
Yeah, absolutely.
Seve, thank you for letting me ramble for a while. I appreciate it.
No, that was great. That was fun.
Thanks. I'll talk to you soon.
Talk to you soon.
That was good. That was great, actually. I enjoyed that.